Thank you for joining us for the webinar Mobile Automation on AWS Device Farm using Appium. The agenda for the day is we'll give you an overview on Appium and its usage, demo of running Appium script in local, AWS Device Farm and its utilization with Appium, Appium and AWS Device Farm integration, and we'll also show you a demo of running the Appium script on AWS Device Farm and give you a brief on the benefits. The presenters for the day is Shailesh Goyal. He's the practice lead QA at KNOWARTH. He's got a zeal towards open source technology. QA practice lead at KNOWARTH. Wide experience in automation with Selenium, JMeter, SOAP UI, mobile, backend testing, and team management. You can follow him at Twitter on Shailesh_QA. The second presenter is Rishal Bhatt. He's a senior consultant at KNOWARTH, test automation engineer, blogger, keen on mobile technologies, and he's expert in JMeter, APM, and functional testing. I am Rahul, senior marketing consultant at KNOWARTH. You can follow me on Twitter at Rahul Sudeep. So just to give you a brief on KNOWARTH, we believe in delivering excellence through end-to-end solution. We are a 170 plus member team and among 20 most promising IT service company globally by CIO review. Certified resources to ensure quality as we pursue excellence. 100 plus projects served in last 2 years to 50 plus clients, and which are being delivered on time within budget. 60% repeat business because of our quality and client-centric approach. Worked on projects for portal, e-commerce, digital marketing, UI, UX, mobility, product engineering, cloud computing, DevOps, and RIMS. We are partnered with Amazon Web Services, Liferay, and EXO. We follow the end-to-end solution approach, which is from design to support. We go through design, development, deployment, and support. We focus on three main verticals: UX, UI, mobile, and e-commerce. We do UI development, UX consulting, e-commerce portal development, mobile app development, single page application development, and custom application development. We also focus on enterprise solutions based on portal, enterprise content management, and ERP. We also have our expertise in cloud and infra, including DevOps, RIMS, that is remote infra management services, and IT infrastructure consulting. And when it comes to QA, we have done about 100 plus functional testing projects, 20 plus end-to-end performance assessment, 5 plus KNOWARTH automation framework implementation, and 100 plus years of cumulative QA experience. Now I'll move on to the webinar. I'll pass it on to Rishal, who will continue the webinar here.
So hello everyone. So before we start digging into the Appium and its integration with AWS Device Farm, let's first briefly understand why mobile automation is so much necessary. So as we all know that there is a mobile app out there for possibly everything you can imagine. And as per the statistics, there are in iOS and Android App Store, there are more than 2 million of applications are there, and the count is increasing at a speed we cannot even imagine. So additionally, majority of all the web applications are responsive nowadays. So needless to say, mobile testing is becoming more and more crucial and important. Now, as we all know, there are countless devices and tablets available in the market, that too in different OS versions and platforms. Now, to test the behavior of your application on such wide variety of devices, it is nearly impossible to manually test all the functionalities. Even if you have all the devices that you need for testing, the testing becomes too much tedious due to the repetitive task. because every time the newer version of the application gets deployed, we need to verify all the functionalities that we have developed so far. So to overcome this problem, yes, we have a solution, and the solution is mobile automation. There are many tools and frameworks available in the market for mobile automation. But for this webinar, we are going to focus on Appium. So let's look at the introduction of Appium, and let's briefly understand the Appium architecture. Now, first of all, Appium is an open source tool for automating native web-based, mobile web-based and hybrid applications for iOS and Android platforms. Now, the biggest advantage of Appium is that it supports cross-platform test execution. So what it means that test scripts written in iOS and Android platforms use the same API. So that enables the large amount of code reuse between Android and iOS test suites. So let's put it in simple words. If you write your Appium test scripts for Android version of the application, you can use the same code for the iOS version as well. Now, let's talk about Appium. Appium is nothing but it's just a wrapper that converts your Selenium WebDriver code into iOS and Android commands. So if you are aware about Selenium WebDriver, you are already halfway there. Then you just need to understand the fundamentals of Appium and its architecture. Now, whatever the languages are supported by Selenium WebDriver, Appium supports all those languages. So you can write your test scripts in Java, Ruby, JavaScript, C#, and all those languages supported by Selenium WebDriver. Now, last but not the least, the last advantage of Appium is that it does not require the source code of the application. So that means you can test directly that application which you are supposed to deploy on the marketplace. Now, why it happens? Because Appium automatically converts the native view of the application into web view while automating. So these are some of the points about Appium and its introduction. Now let's talk about Appium architecture to understand the functioning in more detail. Now in this webinar, we are going to demonstrate Appium execution on the Android devices. So the architecture we are going to discuss is for the Android. Now the iOS version of the architecture is slightly different from the Android version, but it uses the same concept, so you can relate easily. Okay, so now Appium at its core is a web services that exposes the REST API. So what it does, it connects with the client sends all the requests to the server, and it receives the connections from the client wherever WebDriver code exists. It listens to those commands, performs the actions mentioned in the commands on the mobile devices and the simulators, and capture the HTTP response representing the actual result of the execution. So in short, Appium acts as a bridge between your Selenium WebDriver command and your mobile devices. Now, to set up this bridge, clients initiate a session with the server by sending the post request to the server with a JSON object called desired capabilities. Now, upon successfully listening to this request, the server initiates a session and it provides the session ID back to the client. Now, this session ID is being used to send the further commands during the execution. So this is how the connection is established in Appium architecture. Now, the desired capabilities are the set of keys and values sent to the Appium server to tell that what kind of automation session we are interested in starting up. So there are various kinds of desired capabilities available to set the exact nature of the automation server. For example, platform name, there is one desired capability called platform name. It is set to, if it is set to Android, then the Appium server will start the Android session. We can also set the device name, Android package, new command timeout, etc. And there are many more such capabilities that Appium supports. So this was the brief introduction of APM architecture. Now we will move forward with the demo of running the Appium script on local simulator.
Before we move ahead for the demo, anybody who's got questions regarding the webinar can post in the question section on the right. Thank you.
Okay, so moving ahead, we have already prepared a Appium test scripts, the same script we will execute on the AWS Device Farm as well. Now, for the demonstration purpose, we have automated KNOWARTH Technologies' own product, which is KConnect, and which is an HRMS application used by KNOWARTH employees and the customers as well. So let's look at the application. Okay, so this is the KConnect application. So our execution will be like this. The first user will land on the login page. He will log in with the valid credentials. Then post login, user will be landed on the home page where he will search with the employee name from the top search bar. He will get the list of employees, and from the list he will click on the selected employee name, and there will be a pop-up opening, and then he will verify few variables on that pop-up, and then it will close that pop-up. After closing the pop-up, user will be logged out from the execution from the application, and the execution will be completed. So let's see how it happens through Appium. Okay, so as you can see, this is the Appium webinar Java class that we have prepared. So these are the test methods where our Selenium WebDriver code exists. The setup method is containing all the desired capabilities which we have already discussed. So we have set the platform name as Android, the device name as Nexus 5 API 23, which is the name of the simulator on which we are going to run the execution. We have defined Android package and the app activity as well. Now we will start the execution. So before we start the execution, we need to start the Appium server. So here is the Appium window. So by clicking on the play icon, play button, we will start the Appium server. Okay, so Appium server has been started. So now the bridge has been connected. So your Selenium commands now can run through the Appium and can be executed on the simulator which you have connected. Now we will start the execution by running this testNG.xml. So first of all, it will execute the setup method where all the desired capabilities will first launch the application, and now the Selenium commands are being executed. So first it will type the username and password, then it will log in into the system. So post login, it will search for the employee name. Then it will click on that particular employee, it will verify a few things, and it will log out from the application. Okay, So we have successfully executed the Appium script on the local simulator. Now let's go back to our Java class. So what we have done is we have launched the Appium server. We have executed our Appium script on the simulator. Now this launching activity, we can launch the application in two ways. Okay, so first way we have done is we have defined all the desired capabilities in the setup method. So desired capabilities launch the application and it execute all the commands on the selected connected devices. There is another way through which we can pre-launch the application. So that is done through the Appium. Now let's look at how we can do it. So first we need to terminate the server which we have started. Okay, so now if you want to pre-launch the application, then you need to go to this general settings section where you will see an option pre-launch application. If you select this particular option, then what will happen? Appium will launch the application before the Selenium command starts its execution. So your application won't get launched through the code. Appium will automatically launch the application before starting the execution. So now to pre-launch the application, we need to do few more settings as well. That is under the Android settings section. Here you can choose the application which you want to install and launch. So by selecting this option, you will get this field enabled. Here you can choose the application over here, and when you select the application, all these fields gets pre-populated. This package, launch activity, wait for activity. So these are all the fields gets pre-populated. So if we are taking this path, then we don't need to define the desired capabilities on the code level. Now, why it is important? When we will run the Appium script on AWS Device Farm, AWS Device Farm won't need the desired capabilities. So in that way, we can, so in AWS Device Farm, for each and every device, there will be a setting over there which will pre-launch the application before the execution starts. So this is another way of launching the application. Okay, so this is all about the demo of running Appium script on local machine. Now we will move further with our presentation. Okay, so the next slide is the introduction of AWS Device Farm. So what is AWS Device Farm? It is an app testing service hosted by Amazon Web Service. It provides the platform to test and interact with the iOS and Android and web applications on real mobile devices and tablets. Now, this AWS Device Farm can be utilized mainly in two ways. The first one is automated testing of app using testing framework. You can choose any testing framework for your code structure, and you can use that framework. You can upload that framework on the AWS Device Farm, and you can do the automation testing of your application on the selected devices. The second one is the remote access of the devices for real-time interaction. You can directly install your APK or application on the devices on AWS Device Farm, and you can manually interact with your application as well. So these are two main benefits of using AWS Device Farm. Now, the next slide is about why Appium with AWS Device Farm. So we need to know why we would integrate the Appium script on AWS Device Farm. There are many benefits. Some of them are listed over here. The first one is parallel execution. So parallel execution is very essential for reducing the effort and increasing the productivity. So when you are doing the execution manually, let's say you want to run your Appium script on 10 different mobile devices. If you are doing it without device farm, then you need to have all those devices available with you. You need to connect all those devices to your computer, and to run the Appium script on all those 10 devices, you need to start the 10 different Appium nodes. So that setup is difficult to maintain. So that is one of the issue. Now Appium itself provides the simultaneous execution, but when it comes to the devices, it is bit complex. The next one is the test coverage on multiple mobile and tablet devices. We cannot have all the devices available with us, but the AWS Device Farm provides us thousands of devices and tablets which we can use to interact with our application, to automate our application. So that is one of the biggest advantage of AWS Device Farm. When we are going without AWS, and when if we are setting up all those physical devices, it is an expensive setup to buy all those devices and do the setup and everything. So these are more, because of these challenges, we want to integrate Appium on AWS Device Farm. So now we will see how this integration actually works. And now I will hand over to Sailesh Gohel, who will present the actual integration of Appium on AWS Device Farm.
Thanks a lot, Rishit. Hello, everyone. Shailesh here. So we have just seen how we can run Appium script that is created using Java and TestNG in a local machine. Instead of simulator, you can also connect your physical device and you can run your script on that particular machine. If you have connected with two different devices and two different Appium server are running, you can also do with the parallel mode and all these things. But if you want to like test with the n number, like higher number of devices and all, so the cost and so many things are coming into the picture, and that is why we are going with the AWS. So we'll see how we can utilize the same script that Rishil has shown, to AWS Device Farm and execute on more than one devices. So as we already seen in previous slide that AWS Device Farm support multiple frameworks. So it's not necessarily that you need to work with Appium using Java and TestNG. You can also go with Appium, Java, JUnit. You can use Appium with Java and TestNG. If you don't want to go with Java, you can go with Python with Appium. If you have script created with Calabash, you can use those. And also you can use Android instrumentation UI automator as well. So these are a couple of things that Device Farm support. So whichever tool you have used to create the mobile automation scripts for your project, you can utilize those scripts, them into certain uh, stuff and upload into the AWS Device Farm. So we'll see that how we can do that, particularly for the Appium script using Java and TestNG. Before moving ahead, we need to know that which are the prerequisites we need. So we need to have the latest version of Appium installed in our machine. You can go with the older version as well, but the latest one is good to have. You need to have the Java IDE, be it Eclipse or Jenkins or it can be IntelliJ IDE, anything. We'll use Eclipse over here. So that IDE is required to just create and debug our code. You should have one Appium script written in Java and TestNG, and that project should be of Maven nature. Why Maven nature? Because we need to build our project in such a way that it create one package that bundle all the things. And for that, AWS required the Java project to be of Maven nature project. So the project that Rishil was showing was the Maven project only. And last and the most important thing is you should have a valid AWS account to access device farm with IAM user permissions. These IAM user permissions are a kind of permission using that the device farm can do certain changes in the application and the device itself, like it needs to read some config, etc. And that time it is used, permission will be required. So that permission should be there. Whenever you create a AWS account, your user will have those IAM permissions by default. But if you are using your corporate account and they have created one login for you, you may need to check with your IT department or admin whether you do have such permissions with that login credentials or not. So now to move ahead, we'll see like how and what AWS device farm expect to utilize the same script that we run in local. So we have certain things in our script. We have test scripts. We have some other code to like read the data, etc., and all these things. As well, we have so many dependency jar files. So we need to bundle all these jar files and scripts, everything, and wrap them into a zip format. So we can upload that particular zip into AWS Device Farm and we can run our test. So we'll see step by step how we can do that. What are the things we require to convert a normal Maven project that we just now see into a AWS supported project. So the first step, as I told, the project should be of Maven nature. We would have form.xml file. So we need to set the group ID, artifact ID, version, and the packaging. The packaging should be jar because we want our test script and everything to convert it as a jar file. The artifact ID and version will be used to create a name of the jar file. So the jar file name will be artifact ID hyphen version hyphen test or jar, and that jar will be used in a AWS device farm to execute our test. The next step is we need to add a couple of plugins in our form.xml file. The first plugin is we need to add Maven jar file plugin. That plugin will help to create one jar file of all the test scripts that we have written. So let's say in our project we have a couple of test scripts we have written under SRC test Java or SRC test folder. That plugin will pick all those class files or all those test scripts and bundle them into a one jar file. And that jar file will be uploaded to AWS. Another step, step 3 will be we need to add one more plugin, that is a Maven dependency plugin. That plugin will copy all the dependency jar file. Be it like, let's say we are using Selenium Java client libraries, we are using POI libraries to connect with Excel, we are using some test.ng, so we do have this test.ng jar file and all this. There are a couple of jar files that particular project require. So this plugin will copy all these jar files into a specified directory. So that directory will be this output directory. So in my project, the path will be my project root directory. Inside that, there will be one folder created or one directory will be created with the name dependency hyphen jars. And inside that, all my jar files will be there. Once we are done with that, the next step we need to do is we need to create one assembly XML file. We will call it a zip.xml file. This is required from AWS. You can find that particular XML file from AWS tutorial as well. So this zip file will copy that dependency jar directory and the jar file that contains all the test scripts. It will bundle everything and create one zip file out of that. So we need to put that particular XML file under SRC main assembly folder. Once we are done with that, we need to add one more plugin into a form.xml file, that is a Maven assembly plugin. This plugin will pick all these things that the zip.xml file has created, and it will put that particular zip file under our target folder with the name that we have given. So as a in this particular example, I have given the name zip with dependency. So my file name will be zip hyphen with hyphen dependencies dot zip file, and this is the zip file that we will use to upload in AWS. Once we are done with the step 1 to step 5, we need to build our project. So to build that project, we'll use this command mvn clean package. Let's have a look on Eclipse. So here is my form.xml file. So the group ID is Appium underscore POC, certificate ID is also Appium underscore POC, and the version is o.o.1 hyphen snapshot. So whenever I build the package, I will build this form.xml file. One test jar file will be created with the name Appium underscore POC hyphen o.o.1 hyphen snapshot hyphen test jar. That jar file will contain all my test scripts. Then another folder will be created. I have all these plugins as well as the required dependency. Everything will be created under this target folder. I'll just remove everything from my target folder. So now I don't have anything in my target folder. We need to go to the root folder where my form.xml file is located. So this is the path where my form.xml is there. Now I'll run the command mvn clean. So it will first clean and then it will build that package. I'll use one argument to skip the test execution. When I hit that, it will copy all my test scripts into one jar file. Then it will copy all the required jar file into one directory that I have specified. So see, it's copying everything. Now it's building that zip file that I have given the name, that is a zip with dependencies.zip. So the build is success and everything is created. Now let's move back to the Eclipse. I'll refresh my folder, or I can refresh my target folder itself. When I expand the target folder, I have a couple of things created again. So this is the jar file that contains all my test scripts, and the name is Appium POC -o.o.1 test.jar. There is one more jar file created. This jar file contains all the source code of from the SRC main Java and SRC main assembly. If there is anything, maybe we have any user method or anything we have written, it will be there. Along with that, we have this dependency jar folder created. You can see all the required jar files are copied over here. And we have one zip file. This is a zip with dependencies.zip. If you open the zip file, you can see there are three things copied in this dependency jar folder and the two jar files. We require all this thing to upload to AWS, and AWS will utilize this thing to execute our test. To move back to the slides, so the next step, the step 7, is upload this particular package into the device farm and then move on to the test execution. Now, Rishit will show you the demo then how we can actually upload and do the things in AWS Device Farm. Thanks.
Okay, so hello everyone. Now we have everything ready to run our Appium script on Appium device on AWS Device Farm. So we have the APK file, we have the zip package containing all the test files and dependencies, and we have AWS user account with IAM user permission. Now let's see how it is done. So there are around 7 steps, 7 simple steps through which we can complete this process. First, we should log in into the AWS Device Farm with proper user credentials. The next step is we need to create a new project, or we can use the same existing project where we want to upload our test package. Now, the step 3 is to create a new test run. So this step we need to do each and every time. We need to create a new test run each and every time. The step 4 is to choose your application. So, in our example, we will be uploading the test APK which we demonstrated on the local simulator. We will upload the same APK on AWS Device Farm. The next step is to configure a test, that is the uploading the zip package that we have extracted through our Maven project. The next step is to select the devices and run. So these are the simple steps through which we can execute the Appium script on the device farm. Now let's see how it is done in real. Okay. So we already have logged in to the AWS account, and we are currently on the screen where we can create a new project. Now for this demonstration purpose, we already have created a new project, as you can see over here. So now I will go into this particular project. Okay, so as you can see, the create a new run button is enabled over here. When you click on this button, a new run gets initiated where you need to define and configure all the settings. So now I will click on create a new run. Okay, so the first step is to choose an application. So here we have the native application on Android or iOS. So here we will upload the APK file on which we are supposed to execute. So this is the APK we will be uploading. So once the APK is uploaded, we will get a success message, and then we can move to the next step. Okay, so it is the processing, it is validating the APK, and we have successfully uploaded the APK. You can also change the run name from this field. Now I will click on the next step button. Okay, so here you can configure a test. So in our local, we have created an Appium test with Java test ng. If you have created with Java JUnit, then you need to select that option. Now AWS Device Farm also provides few inbuilt frameworks which you can select from this list. Here we will select the APM Java test ng. Now AWS has asked us to upload your package over here. So now we will click on the upload button, and we will upload this zip with dependencies package which we have extracted from our Maven project. So it will take few seconds to upload your package on the AWS. So once the package is uploaded, you will get a success message. But if there is if there are some errors in your local and the package has not been extracted successfully, then you will get an error over here, which you can debug and solve what the problem is. So once the package is uploaded, then we will move to select the devices on which we want to run our test. Okay, so it has successfully uploaded the package. Now I will click on the next step button. Okay, so here you can select all the devices you want for your execution. The default selection is the top devices which AWS has provided. You can also create a new device pool, and you can put all the desired devices on that pool. So for this webinar, we have already created one pool, which is webinar device pool, in which we have added 2 devices. So I have selected that particular device pool, and now I will click on the next button. So this is the configuration related to the devices. You can keep it as default, and you can make some changes as per your requirements. So right now we will keep it as default, and we will go to the next. Okay, so this is the review screen where you can review your application, your taste, and the devices which you have configured in the previous pages. So everything looks good, and now I will confirm and start the execution. Okay, so once I click on this button, AWS Device Farm will extract all the test files and dependencies from the package that we have uploaded. And first, it will launch the application on the selected devices. Then it will execute all the Selenium commands on the devices. Then once the execution is completed, we will see the set of results over here. So this execution will take long, it will take much time. So yeah, it will take around 5 to 10 minutes, even more than that. So for the demo purpose, we already have executed few test runs with the same package and on the same APK. So that we can look at how the results are being demonstrated on the device farm. So I will click on this particular test run. So you can have n number of test runs over here. So each one will be displayed as a row over here, and if any command fails or if you get any error in the execution, you will get that particular section in the red color. So now I will click on this particular execution. So as you can see, we had executed the script on 2 devices, Samsung Galaxy A5 and Samsung Galaxy E5. AWS provides you many sorts of results. You can click on this particular device to see the result for that particular one. So this is one of the biggest advantage of using AWS Device Farm for automating your Appium scripts. It provides you the whole video of the execution. So we can directly play it over here, and we can verify that all the commands that we had mentioned in the Selenium WebDriver has been successfully passed or not. So this is the biggest level of verification that we can say. Plus, Device Farm also provides the log files related to the execution, which you can download from this button. If you click on this button, it will give you the log file, which you can verify to understand the nature of your previous execution. So this is all about the execution on the device farm for Appium. We have successfully integrated our test scripts on the AWS device farm. Now we will go back to our presentation. Okay. Now let's understand the benefits of using this integration that we have discussed in this webinar. So the first point is faster test execution. So as we already discussed, executing the test scripts manually, it takes a lot of time and lots of human resource energy. But if you do this integration, this is one-time integration. If you do it, then you just need to upload your package and upload your APK, and you need to start the execution. So once the execution is started, you don't need to worry about anything. Once the execution is completed, it will give you all the results. Now, the second point is cost effectiveness. If you go to buy all the devices that you need for your execution, it would be more expensive. But AWS Device Farm provides you thousands of devices, mobile devices and tablets, which you can use for automation and remote access as well. And the last one is the accuracy. So same test to run on multiple devices by automated scripts. So there is a zero chance of human error or any sort of error. So at the end of execution, as we saw that AWS provides us the stack of our execution log, the whole video recording of our execution, and we can also integrate the screenshots into that. For that, we need to do the separate settings, separate level of coding for that. If we do that, Appium script will be executed on Device Farm, and Device Farm will capture the screenshots on the regular intervals, and it will, at the end of execution, it will provide you the screenshots which we can verify to know the success or failure of your execution. So these are the benefits of using Appium on AWS Device Farm. So now we will move ahead with the question and answers.
Thank you, Rishal. Thank you, Sailesh. We have received a lot of queries. Thank you for all the questions that you have put in. We'll take up as many as possible. Sailesh, if you could help me out with the question from Hugo, who's from France. If I have my test scripts written in Appium using my own framework, can I utilize those and run on AWS?
Sure.
Should I repeat the?
Yeah, can you please repeat?
Yeah, I'll just repeat the question. Hugo is asking if I have my test scripts written in Appium using my own framework, can I utilize those and run on AWS?
Yeah, sure. Yes, we can. Actually, what we need to do is, first thing is that we need to convert our project as a Maven project, and we need to make the all our folder structure that similar as what I have shown in my demo. That all the test scripts should be on the test SRC for test, and we need to add that assembly, separate XML file, and everything. And the rest of the things that Maven will take care. So yes, we can.
Okay. Thank you, Sailesh. Second question is from Audrey, who is from Germany. Can we integrate these device farm tests with continuous integration and deployment?
Yes, Shailesh again. There is again the beauty of AWS Device Farm that it actually it has that plugin for the Jenkins. So in Jenkins, you can use that AWS Device Farm plugin, and within Jenkins, for your CD pipeline, your continuous deployment pipeline, you can set one particular stuff for that. You can even select the device pool from that, or what sort of devices you want to use. You can select what nature of framework you want to go with, whether you want to go with the Java testing, APM, or what. You can select another thing like calibration, everything. You can give the name of the APK that you want to use and everything. Plus, you can also directly upload the zip file that we have uploaded to AWS. You can give the path of that particular zip file into that particular settings, and when that deployment hierarchy will run in your CI/CD pipeline, it will use all those devices that you have identified in the test pool. It will upload that zip file and the same thing will happen that we just now showed. So it is possible to use AWS Device Farm integrate with our CI/CD pipeline. Thanks.
Thank you, Sailesh. Question from Samveer Mahapatra. He's asking, hi, I'm using physical device to automate my native app. I need to execute the test scripts in parallel to two Android devices. If you could suggest anyone. I'll just repeat the question again. Probably Rishal will be helping you out with the query. Hi, I'm using physical device to automate my native app. I need to execute the test scripts in parallel to two Android devices.
Okay, so for that, first of all, you need to install that native app on all the devices that on which you want to run, and you need to connect both the devices with your system. And if there are two devices, then you need to start the two APM nodes. Okay, so in our example, we have started one APM node. So the number of times you want to do the execution, you need to start that many APM nodes. And once you start the execution, your test script will be executed on both the devices. Thank you.
Thank you, Rishal. Another question from Angelica. Probably this will be handled by Sailesh. How many maximum number of devices can I select in a device pool at a time to run my test?
Number of maximum devices, as per what AWS has mentioned, there is no such limitations. You can select as many devices as you want. There is some limitation that simultaneously device farm is executing the test on around 5 devices, and once they're done with that particular execution, they'll pick on another device. But yeah, in your device pool, you can use all the devices if you want. But that particular number of devices will increase the execution time. So it will be there, definitely.
Yeah, probably we'll have question, last question. We'll take up as it's from Rajan. Does automation if iOS app is in iOS app is different on AWS Device Farm? That what we see in the webinar. Probably we showed the Android version. That is why the iOS question popped up.
Hi, this is Rishal. There is no difference actually. So the same code which you have created for the Android version of the application, the same code you can use for the iOS version as well. But for the Android in local, we are using the Android SDK. But to open the iOS, we need to use the Xcode. That is the only difference. The same code you can use.
Okay. Thank you, Rishal. We'll take up one more, which has been a popular question. That is, I don't know anything about APM, but want to use AWS Device Farm to leverage large number of devices. How can that help me?
Definitely. So Device Farm is not only for the mobile automation testing. You can create your own AWS account. You can go to the device farm and select any device you want. You can upload your own APK of your mobile app or the IPA file of your iOS app, and you can just play with that particular app that we do with for the functional testing, like in the physical device or simulator. We just do certain things by our own. We can perform the same manual testing on device farm, and those are the actually emulators connected with the real devices. So you will get the result that any physical or real device gives you. So AWS is not only for the mobile automation. You definitely can do manual testing on n number of devices that you want. And one more thing, like let's say you have selected one device, let's say you selected Google Pixel, and you have performed certain scenarios of functional testing or manual testing on AWS Device Farm. And once you are done with that particular session, Device Farm itself will have captured whole video of what all the actions you have done. It also has that log file that will be helpful for the developers more, and anytime you want to take the screenshot, you can take the screenshots and everything. So it is not only like just play with the particular mobile and okay, we just need to just play with the mobile and we finish with that. But we can get the logs, screenshots and videos as well. So that is again a beauty of the AWS Device Farm. Thanks a lot.
Thank you. Probably we'll wrap up. We have made a note of all the questions that are pending to be answered. We'll email you and get back to you on that. Thank you for being such a wonderful audience. And for any queries related to the webinar or AWS Device Farm, please mail us on marketing@knowath.com. Thank you.